Hello, everybody. I'm back with another video. This time, a video related to the stresses that are developed in the pressure vessel, particular thin pressure vessel. So, as always, guys, I appreciate if you like the video and subscribe to my channel. So let me go ahead and remove my, picture so I can flatten this and write on my iPad. Okay, get rid of that picture. So let's read the problem, guys. So here we have what? A pressure vessel consists of spirally wrapped steel plates that are welded at the seams, the orientation shown. So the beta is 35 degrees here, this angle, right? Which color? Right. So what is it, by the way, what is a thin pressure vessel? A thin pressure vessel, and this is a cylindrical pressure vessel, obviously. A thin pressure vessel, the definition is that the ratio of inner radius to the thickness has to be at least 10. Let's see what is the R ratio here. So the diameter, inside diameter is 16. So the inside radius is 8 inches. And the thickness is 0.375. So if we do 8 over 0.375, I believe this ratio is 21.33. So this is well within that definition of thin pressure vessels. Remember, you need at least 10. So it says the ends of the cylinder are capped by 2 rigid plates, right? And then the gauge pressure inside shows this is the internal pressure, 260 psi. And the tensile axial load, this load is 15 kips, so 15,000 pounds. All right, so what we want to find is what's happening at this sim, right? In other words, what is the normal stress developed here? I'm going to call this actually sigma x prime. I'm going to use the transformation equation. And what is the shear stress developed here? And this is, remember, in the transformation equation. And I have videos on that. If you look for it on YouTube, you'll see that that's called tau x prime, y prime. All right, so that's what we're trying to find. All right, so how do we go about doing this? First, we have to figure out what is the stress element of any point on this pressure vessel, on the outside of pressure vessel. So you guys know that for a cylindrical pressure vessel, first of all, there are 2 types of stress. One is called the longitudinal stress, which is typically denoted by the notation 2, I mean, this subscript 2. And then one is called the hoop stress, which is along the hoop, like a basketball hoop, and it's denoted by sigma 1. Now, sigma 1 is the internal pressure times the inner radius divided by thickness, for which I have the ratio here, right? And the longitudinal stress, sigma 2, is half of the hoop stress. So hoop stress is actually twice the longitudinal stress, so divided by 2. All right, but look, guys, in the longitudinal direction, we also have the normal stress as a result of this pressure applied along the longitudinal direction, meaning P, this P here is actually force, let me call it F, not to be confused with the pressure. Internal pressure is 260. So let me go ahead, guys, and do this. Look, guys, sigma 1 is PRI over T, right? So internal pressure is 260 psi. RI over T, see this? RI over T, I've already calculated that. It's 21.33. So you could either put 8 over 0.375, or you already have the ratio. So that becomes 5,546, roughly, psi. Now, this guy, P sigma 2 is what? Or sigma, let me say, in this direction. So you see now, if you look at the stress element here, you already got the hoop stress. That's this guy. But this one is going to be what? It's going to be this guy plus the stress develops here. So I'll still keep that as sigma 2. We'll call it sigma longitudinal, sigma L. It's up to you what notation you want to use. So this is what? The normal stress is F over A. So we already know that this guy is 260 times 21.33 divided by 2. Remember, this stress is half of the hoop stress, right? Then in addition to that, we have also the 15,000 divided by area. Be careful, guys. You're talking about a hollow shaft, right? A hollow cylinder, right? Like that. So the area is this area that I'm showing you. So what we got to figure out what is the outer radius. So if the inner radius or the outer diameter, I'm sorry, inner diameter is 16 inch, the outer diameter would be what? 16 plus 2 times 0.375, 2 times the thickness, right? So this happens to be 16.75 inch. So I can go find the area. What's the area of a circle? In terms of diameter, pi over 4, outside diameter squared minus inside diameter squared. So if you do the calculation, this sigma longitudinal, I call it LONG, which would be the sigma along this direction, right? Becomes what? Becomes the sum of those two become 3,550. All right. So now I have a stress element which looks like this. This is the stress element on any point on the outside of this pressure vessel. I got the hoop stress, which is 5,546 psi. Same thing here, right? And then I got the longitudinal stress. By the way, this is 50. I don't know why I put 51, because I can't read my own handwriting. All right. So in a way now, when we go to our transformation equations, so remember, transformation means what? This is our x-axis, this is our y-axis, right? So this is basically your sigma x, this is your sigma y, and you don't have any tau xy. There's no shear stress around this, right? Tau xy is 0. Transformation basically means that now you want to go to a different plane, right? Like that. And the angle in the equation that I'm about to show you is theta. This theta actually, guys, look, happens to be the beta. So theta and beta in the transformation equations are the same and 35 degrees. So what is happening at the seam, which is coming at an angle of 35 with respect to vertical? So remember, the transformation equations are as follows. Again, I do have a video on this, so you can check on that. So we have an average stress first, then we have the difference of these stresses divided by 2 times cosine 2 theta plus tau xy sine 2 theta. Of course, there is no shear stress, right? It's 0. So now if you go ahead and plug in, our 3,550 plus 5,546. Remember, sigma x, sigma y are basically the stresses that are calculated, right? And then 3,550 minus, the 5,546 over 2 cosine of what? Cosine of 2 times 35 is what? Cosine of 70. So if you do the math here, this comes out to be 4,210, roughly. And then what about the shear stress on the seam? There's a formula for this one. You can do the plug-in, sine 2 theta plus, remember, these are your typical transformation equation, right? This one, and this one. Plus tau xy cosine 2 theta, right? And then, of course, tau xy is 0. If you calculate this one, you get 938. By the way, units is PSI, obviously. All right. So what do we have basically? I'm running out of space here, but basically what you have is that on the seam of this is 35 or beta, right? Right there, you will have stress, a normal stress, which is your sigma x prime of 4,210, and a shear stress developed on that seam, right? Which is the 938 psi. Okay. So I hope you like this video. As always, guys, I appreciate if you leave a comment as I said, subscribe to my channel and like the video. I'll be back with more videos soon. Thank you and have a great day.